Good morning to all. My name is Franklin Gino, Assistant Professor in the Department of Information Technology, VSB Engineering College, Karu. So today we are going to discuss the computer networks. Okay. What is meant by computer networks? Why we are using computer networks? Okay. So if you're having a number of systems, okay, all systems having the data. Okay. So without networking, you can't able to take the data. Okay. So you can able to take the data with individual systems. Okay. If you are not taking the data through the networks, right? So computer networks is the backbone of modern digital communications, enabling the exchange of data, information, and resource between connected devices. Okay. So in this figure, so laptop, then desktop, and some networking devices are there. Okay. All devices are interconnected. Okay. So through interconnected, we have to share the data from one system to another systems. Okay. So computer network is a backbone of modern digital communication. With the use, what is the use of computer networks means we can enable or exchange the data, okay, or transfer the data between one system to another system. Okay. So this is the main purpose of computer networks. Okay. In our day-to-day life, okay, we have to a lot of internet browsings to cloud computing and beyond this. Okay. So internet browsing is very, very important in the day-to-day life. Okay, we have to use for that is networks. Okay. Then what is computer networks? So it is an interconnected device. Already we said, so it is an interconnected device. A computer network is a collection of interconnected devices, such as maybe it's a computers or smartphones or servers. Okay, so that can communicate and share informations with each other. Okay, so these systems or these devices can be shared the informations. Okay, so through the internet. Okay, so that is computer networks. Okay, so we have to exchange the data from one system to another system. Okay, we need some protocols. So that is called communication protocols. Okay, communication protocols. What is meant by communication protocols? So networks that is used standardized communication protocols like TCP/IP. Okay, so TCP/IP in the sense, so TCP means transmission control protocol. Okay, so if you change the data or exchange the data from one device to another device, okay, so we have to need that is protocols, that is transmission control protocol. Okay, so which is used to establish rules. Okay, protocols in the sense is a set of rules. Okay, so established rules and procedures for data transmission and reception. Okay, so this is the main use of these protocols. Okay, so without use of these protocols, we can't able to exchange the data. Okay, can't able to exchange the data from one device to another device. Okay, so this is communication protocol. Third one is resource sharing. Okay, resource sharing. What are the resources can be shared through the network? Okay, so networks allows for the sharing of hardware, software, and data resources, enabling collaborations and improve productivity. Okay, so this is resource sharing. Okay. So in this computer networks, we have to use some basic network topology. Okay, the help of that is network topology we can use to share the data. Okay, first one is bus topology. Okay, what is going to be bus topology? In the bus topology, so all the devices are connected in the single cable. Okay, in a single cable, all the devices are connected, forming a linear structure. Okay, that is bus topology. That in the sense all the systems or devices are connected through a single cable. That is bus topology. Okay. Second one is star topology. So here the devices are connected to a central hub. Okay, one hub is there. So in this hub, through this, all the devices are connected in this hub, allowing for easier management and troubleshooting. Okay, so if any problem can be occur in this network, okay, in this star topology, we can easily identify and easily we can rectify that problems. Okay, that is star topology. So next one is mesh topology. Devices are interconnected, creating multiple paths for data to flow, providing redundancy and reliability. Okay, so in this mesh topology, so the devices are interconnected, or so multiple paths, the data can be flow, that is multiple paths. Okay, so providing that is redundancy and reliability. Okay, so these are the basic topologies. You have to share the data from one system to another. Okay, this is the basic topology. So next one is protocols. What are the protocols we have to use to share? Okay, share the data from one device to another device. What are the protocols we need? First one is, I already told, TCP/IP. Okay, so transmission control protocol, the fundamental set of protocols that enables communication on the internet and most modern networks. Okay, so fundamental set of protocols in the sense some set of rules. You have to share the data from one system to another system. Okay, so TCP is a main protocol, that is the data can be changed from one system to another system. That is transmission control protocol. Next one is HTTP, hypertext transfer protocol. So what is the use of this protocol? So these protocols can define how web browsers and servers communicate to deliver web pages and online content. Okay, so what is the use of HTTP means? We have the web browser. Okay, we have to we need to one web page. Okay, for example, so www.amazon.com. Okay, so in the web browser we have to type, that is www.amazon.com. Okay, so the browser can be communicate with the web server. Okay, web server, and we have to get the particular web page in our system. Okay, so with the help of this protocol, we have to easily get the particular web page. Okay, so this is the main use of this HTTP protocol, hypertext transfer protocol. So next one is, that is SMTP, POP3, and IMAP. So these are all the email protocols. Okay, protocols that govern transmission and retrieval of email messages. Okay, so next one is FTP, file transfer protocol. This protocols used for transferring files between computers over a network. So these are the some types of protocols we need to exchange the data from one device to another device. And this one, that is network hardware. What are all the network hardware we have to use in the modern society? Okay, first one is a router. So router in the sense is a direct and manage the flow of data between the networks. Okay, so for example, so there is two different areas. Okay, so each and every area is having one router. Okay, so in this router can be communicate for the different areas. Okay, so direct and manage the data flow. That is a router. Okay, so switches. Second one is switches. Switches means so in our lab, that is in switches is there. Okay, so connecting devices within the local area network and direct the traffic between them. Okay, so if any traffic can be occur in this network, the switches can be easily manage the traffic. Okay, that is switches. Modems. So the expansion of modem means there is modulation and demodulation. Okay, so translate the data between computers, digital format and an analog format suitable for transmission over the telephone line or cable. Okay, so modulation. So take the signal to modulate and demodulate the next side. Okay, that is the main use of, that is modems. The next one is network card, that is NIC card. NIC card in the sense network interface card. Okay, so what is the use of this network interface card means? So provide the physical interface for devices to connect the network. Okay, so if you want to connect your system through the network, okay, so we need, that is NIC, that is network interface card. Okay, that is NIC card. So these are the basic network hardwares, right? And the next one is network software. What are all the softwares we need to exchange the data from one system to another? What are the softwares we need? Okay, so first one is operating system. Okay, so what is the use of operating system? So here, manage and coordinate network communications at the core system level. Okay, so manage the communication levels, we need the operating system. Next one is network applications. Okay, network applications. So the use of network applications, where the applications we used, okay, provide user-facing tools and services for communication. Okay, first one is communication, next one is collaboration and information sharing. Okay, so this is the main purpose of network applications. Okay, resource sharing and communication. Third one is network protocols. Already we discussed, that is implement and standardize the rules and procedures for data exchange. Okay, for data exchange. So next one is network security. What is meant by security? Okay, so the unauthorized persons can be stolen by data. Okay, so we can avoid for that. We have to use for some networking security. Okay, and the first one is that is firewall. Okay, monitor and control incoming and outgoing network traffic to protect against unauthorized access. Okay, unauthorized access. Some of this unauthorized persons can be stolen our data. Okay, we have to finish, or we have to neglect that systems we need, that is a network security. Okay, second one is encryption. So encryption in the sense, you have to send the data. Okay, so through that ciphertext, that text can be so modified into ciphertext through the networks. Okay, in the decryption, we have to decrypt the data and send the original data for the receiver side. Okay, so encryption means scramble data to ensure confidentiality and prevent eavesdropping during transmission. Okay, so the original data so cannot be shared for that particular device. Okay, it can be so modified into ciphertext. Okay, add the ciphertext. Okay, and send to the send from the sender side. In the receiver side, the data can be decrypted. Okay, and in the original data can be so received in the receiver side. Okay, so with the help of encryption. Then access control. Okay, we have to give some access control to the particular persons. So restrict user and device access to network resources. So based on defined policies. Okay, so we need what are the uses can be used for this particular data, and what are the uses cannot be used for this data. Okay, we have to restrict for that the devices and users. Okay, that is access control. So these are all the network securities. Okay, then the next main function of the network is performance. Okay, so how the data can be sent. Okay, what is the bandwidth? What is the latency? What is the throughput and packet loss? Okay, so these are all the performance of that is network performance, right? And the first one is that is bandwidth. Bandwidth in the sense the maximum amount of data can be transmitted over a network connection. Okay, maximum amount of data. How much of data can be so transmitted from sender to receiver? Okay, that is a bandwidth, maximum amount of data that can be transmitted over the network connections. Okay, second one is latency. Second performance, that is latency. Latency in the sense the time it takes for data to travel from one point to another point on a network. Okay, okay. So how much time it will be taken from one point to another point? That is latency. The time is taken for data to travel from one point to another point on a network. Third performance, that is throughput. Okay, throughput means the actual rate of successful data transfer over the network connections. Okay, so we have to number of data. Okay, So how much data can be sent from sender to receiver and the successful rate? Okay. How much data can be sent, that is from sender to receiver? That is a successful rate. That is a throughput. Okay, successful rate. And the next performance, that is packet loss. Packet loss means if we can send the data from sender to receiver, some of the packet can be lost. Okay, the percentage of data packet that failed to reach their destination. Okay, we have to send the data from the sender, but that packet cannot be received in the destination side. Okay, that is called packet loss. So these are all the performance of networks. Okay, so bandwidth, latency, throughput, and the packet loss. Next one is network applications, where we have to use the networks. Okay, first one is communication. In the communications, we have to use for that is an email. Okay, we have to send the email and receive the email. Then instant messaging. Then video conferencing. Okay, nowadays most of the places we have to use for that is video conferencing. Okay, and voice over IP. Okay, voice over IP. So these are all the communications. Okay. That is used for the network applications. Next one is collaboration. Collaboration in the sense two things, that is file sharing, cloud storage, and real-time document editing. Okay, that is the collaboration. Then information access, web browsing, online streaming, and remote desktop access. Okay, so these are all the applications we have to use in this network. Okay, network applications. Next one, trends in computer networks. Okay, what are all the trends? So the recent trends used for computer networks. Okay, first one is, that is 5G. Okay, so in the development of this network, you have to use that is faster, reliable networks. That is faster and more reliable wireless network technology. That is 5G. Next one is IoT, Internet of Things. The increasing integration of network connectivity into everyday devices. Okay. Third one is cloud computing. Okay, so we have a lot of data. Okay, and then we have to store the data in that cloud. Okay, the shift towards centralized on-demand computing and storage resources. Okay, so that's we have used for computer networks. Fourth one is, that is software-defined networking, which means the programmable control and manage of network infrastructure. Okay, so these are all the newly trends in the computer networks. Okay, so computer networks are the backbone in our digital world, constantly evolving to meet the demands of new technologies and user needs. This presentation explores the latest trends shaping the future of computer networking. Then emerging technologies in networking. First one is 5G and beyond. Okay. The rollout of 5G networks is enabling faster, more reliable wireless connectivity, paving the way of advancements in IoT, smart cities, and mobile applications. Next one is edge computing. What is meant by edge computing? It means bringing computer power closer to the data source. Edge computing reduces the latency and improves the efficiency of time-sensitive applications. Third one is software-defined networking. Okay. SDN. Okay. SDN means software-defined networking. So SDN decouples the control of data plans, allowing for greater network programmability and adaptability to changing demands. Okay, so that is emerging technologies in the networking. Next one is the rise of software-defined networking. First one is centralized control. Okay, we have to use, so in this diagram we have to use, that is control panel. Okay, so data panel. So this is the SDN controller, right? So SDN separates the control and data plans and allowing centralized controller to manage network policies and configurations. Okay, we have to manage, and the network policies we have to use for that is SDN. Okay. Then second one is programmability. SDN networks can be programmed and automated through APS, enabling rapid development of new services and applications. Third one is flexibility. Okay. SDN provides greater flexibility network management, allowing for dynamic resource allocation on the fly changes. Next one is advanced in wireless communications. Okay. What are the advancements in wireless communication? 5G rollout. The widespread deployment of 5G networks is delivering faster speeds, lower latency, and increased capacity for mobile devices. So next one is Wi-Fi 6 and beyond. Latest Wi-Fi standards such as Wi-Fi 6 and 6E are improving wireless performance and enabling new use cases. Third one is satellite internet. Satellite-based internet solutions are expanding access to high-speed net connectivity in remote and unserved areas. And the next one is cybersecurity challenge. What are the challenges we have to use to face for the nowadays the cybersecurity? Okay. And the first one is that is a ransomware threat. Okay. Ransomware attacks continue to be growing concern, targeting business and organizations of all sizes. IoT security. The proliferation of IoT devices has increased the attack surface, requiring a robust security measures to protect networks. Next one is a zero trust approach, which means adopting the zero trust security model where every user and device is verified is becoming essential for modern networks. Okay, so here, so every user and devices can be verified. That is called zero trust approach. And the next one is AI-driven security, leveraging artificial intelligence and machine learning to detect and respond security threats in real time. And next one is edge computing and the Internet of Things. Okay, IoT devices, that is increased proliferations of smart connected devices generating massive amounts of data. Edge computing means bringing computing power closer to the data source, reducing latency and improving efficiency. Third one is real-time analytics, enabling instant insights of decision making by processing data at the edge. Okay. Next one is network visualization trend. Network function visualization, decoupling network functions from proprietary hardware, enabling flexible software-based deployments. And the second one, virtual network functions, virtualing network services like routers, firewalls, and load balancing for on-demand provisioning. Third one is network slicing, partitioning physical network into multiple virtual networks, each networks and each optimized for specific use cases. The next one is the future of computer networks, AI-driven network management, which means leveraging machine learning to automate network operations and optimize performance. Quantum computing and networks, exploring the potential of quantum machines to revolutionize the data transmission and encryption. Sustainable network infrastructure, designing energy efficient networks and exploring renewable energy sources for data centers. Integrated network cloud platforms, seamless integration between networks and cloud services for enhancing and scalability. Thank you.